Okay, so this is lesson 4, and we are going to be dealing with sum of geometric series. Okay, so exercise 1 is incredibly similar to exercise 1 from lesson 8.3. The only difference here is instead of dealing with arithmetic, we're dealing with geometric. So we no longer have a common difference. We have a we don't have a common difference. We have a common ratio. We're not adding, we're multiplying. Okay, so we have given a geometric series defined by the recursive formula a sub 1 equals 3 and a sub n equals a sub n minus 1 times 2. Which of the following is the sum of the first 5 terms from 1 to 5 of a sub I? Okay, the summation from 1 to 5 of a sub I. So this is, like I said, incredibly similar to exercise 1 on lesson 8.3. So if you need to look back, okay? So you're going to find me this sum. Everybody should be able to do this without my help. So go ahead. Okay, so how many of you started by writing s sub 5 equals a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5? Started that way? Okay, because that's what this is saying, right? So now what I need to do is, since I'm looking for the sum of the first 5 terms, is I need to know the value of each of the terms, right? What's a sub 1? 3. A sub 2 is a sub 1 times the common ratio. What's the common ratio? 2. So what's a sub 2? 6. Okay, plus, what's a sub 3? 12. What am I doing? Good, a sub 4. And a sub 5. Good. And then all I need to do is what? And you get? Good. Okay? So it's the same exact thing we did yesterday, but we're just using a different formula. Okay? All right, so generally I would have us go through and derive this formula, but to be honest, we don't have the time. Okay, so the formula that we're going to be using for sum of a geometric series is going to be the sum of n terms equals a sub 1, which means what? The first term, times 1 minus r. What's r mean? Common ratio, raised to the nth power. What's n? Okay, divided by 1 minus r. Okay, so that's your formula. Now this is on your reference sheet. All right? Okay, you ready to try it? All right, so exercise 3 says, which of the following represents the sum of a geometric series with 8 terms whose first term is 3 and whose common ratio is 4? So I want you to write down your knowns. What are your knowns? What's my first term? Okay, what else do I know? I'm sorry? N, what's N? 8, okay, what else? R, which is, do I need more information for my formula? Okay, so I have S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. So I have everything I need, right? So tell me how to plug this in. S sub 8. Uh-huh. Uh-huh. Good. Good. Please find me my sum of my first 8 terms. So as long as you can determine what those variables are, it's pretty simple. Okay? So you have to be able to read and read well. What'd you get? Yeah, 65,535. Are we okay with that? It's not so bad, right? Okay. So let's look at exercise 4. Find the value of the geometric series shown below. Show the calculations that led to your final answer. So again, this time we're just given a bunch of numbers, right? We have to be able to pull all of our information from there. So let's talk about what we know. We know a sub 1. Good. What is it? Awesome. What else? Good. What's my common ratio? Awesome. What else do I know? Do I know n? No. I know a sub n. Good. What's a sub n? Great. I don't know n, and that's a problem, right? I need to know n in order to find the sum of the terms. So how am I going to find n? The a sub n formula, what is it? What's wrong with using that one? Yeah, it's arithmetic, right? Do I want an arithmetic formula to solve a geometric sequence? Times r, yeah. Good, raised to the n minus 1. Good, that's the formula we're going to use. So you have to be careful of what kind of sequence we're talking about, or series we're talking about, okay? Make sure you're using the appropriate formula. All right, so let's substitute into this. How do I do that? Good? Good? Yeah? Good. All right, how are the 6 and the 2 attached? So can I subtract the 6? We have to divide. Now, can I multiply the 6 and the 2? Why? Yeah, the 2's got that exponent of n minus 1, so can't do that either. Okay, so what do I need to do? How do I get rid of the 6? Divide both sides by 6, which gives me okay. Where would the n minus 1 go if you divide it by 2? Up in the air, just hanging out? Probably not, though, right? Can't do that. We're solving an exponential equation. We could get common bases. What's my other method? Somebody said it. Logs. I could use logs, or I could find a common base. Either way works for me. Which way do you want to do it? Common base. What's my common base going to be? Can my common base ever make my base larger? No. It's always got to be smaller or the same size as the smallest. Same value as the smallest, right? So my common base is 2. How would I write 128 with a base of 2? I want you to put 2 to the 64th power into your calculator. Please. Just do it. Is that correct? No. Because this does not equal this. This equals this. What's 2 times 2 times 2? 8. Do we understand? So what you told me was 2 multiplied by itself 64 times, not 2 times 64. Okay? So again, let's try that again. 2 is going to have an exponent of 7. 2 to the 7th power equals 2 to the n minus 1. I'm sorry? Yeah, so we get 7 equals n minus 1. Yeah. Okay. Now do I have all the information I need? Good, find me my sum. All right, so we have s sub 8 equals 6. No, it didn't, it's gone. S sub 8 equals 6 times 1 minus 2 raised to the 8th over 1 minus 2. What do we get? 1530. We okay with that? All right, so do you see what formula you have to use if you're missing something? Are we using the arithmetic? Why? It's a geometric series. Okay, so you can't mix and mash. They got to go together. All right. Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually. What does that mean? She gets interest compounded annually. What does it mean? Every year she gets 5% on whatever's in her account. Yeah. Okay, Maria would like to determine how much money is in her account after she has made her $500 deposit at the beginning of the 11th year. Okay, so at the beginning of the 11th year, she's put her 500 bucks in. All right, so we're going to determine a formula for the amount, A of t, that a given 500 has grown to t years after it was placed into the account. So we're looking for a formula, A of t. You have done these before. This is not new. We have a formula for when we're talking about interest. Who remembers it? Okay. A equals P times E raised to the RT. We're going to use it for compounding continuously. Are we compounding continuously? We're compounding annually. Different formula. Is the account getting larger or smaller? That's a hint. Yeah, there's a 1 plus in it. 1 plus R, yeah. I need more than that, though. We definitely have a 1 plus R. I need more. Not squared, no. To the T. Okay, I need something else. 2 more things. A what? I need an A, and that A stands for what? Starting amount. Okay. What's it equal to? What's it equal to? What's it equal to? A of t. It's telling you what to write it as. Okay, you have to read, guys. Okay, so, good. We've got A of t equals A times 1 plus R raised to the t. Now, we actually have to put some values in here. Okay? A of t we have to keep. What is A? Yeah, that's the initial amount she puts in. What's my rate? 0.05, 0.05, right? Raised to the t. So this actually winds up being A of t equals 500, 1.05 raised to the t. So there's our nice formula. And this is geometric, is it not? I've got a starting value, A sub 1, times a common ratio, 1.05, raised to the number of terms, or in our case, the number of years. Okay? All right, so using this formula, determine the amount that $500 deposited in year 1, 2, 10, and 11 have earned at the beginning of the 11th year. Does that make sense? Years 1, 2, doesn't really make sense, does it? Yeah. Let's kind of skip that part. We don't really need it. Let's talk here. All right, so based on B, we're not basing it on B. We're going to write a geometric sum representing the amount of money in Maria's account after the 11th year. We're not going to do that either. We're going to go over here. We're going to skip right to D. We're skipping around a little bit. Okay, so we're going to evaluate the sum using the formula above. So we're going to find out if we have all of our information to start, right? So let's talk about what we know. What do we know? What's A sub 1? Good. What else do we know? What? R. What's R? No. We created a geometric, what? No. 1.05. Okay, remember, we created it from this equation. Notice what's in my R spot. 1.05, not 0.05. I'd be cautious with that. All right, what else do we know? What else do we need to know? Let's put it that way. We need N. Okay, so let's talk about the context of the problem. We want to know how much money she has at the beginning of the 11th year. So what is N? Yeah. Works for me, right? All right, find out. That's all the information you need. What? Is NT? Yes. Pause that. Pause it. All right, guys, pause. No, not, hold on. Yeah, you have to pause, literally. Maria would like to determine how much money is in her account after she's made her deposit at the beginning of the 11th year. What hasn't happened at the beginning of the year? She hasn't gotten her interest, right? So we have to kind of backtrack here. Are we going to do it based on 11 years? 10 years, and then we're going to have to do what to our sum? Add 500, okay? Because she put her money in. She's not getting her interest on it yet. Okay, so you want it at the 10th year, then tack your 500 on. Sorry about that, guys. Well, you're talking money. Okay, so what are we going to get? Yes. I need somebody that agrees with that. Can I get a second? You agree? Okay, good. All right, one more to go, guys. Just so I don't forget, if the bell rings while I'm teaching, your homework is to finish up that packet. Okay. All right, person places 1 penny in a piggy bank on the first day of the month. 2 pennies on the second day, 4 pennies on the third, and so on. This person will be will this person be a millionaire by the end of the 31st day? Show the calculations. What do I know? What is it? 0.01. Talking pennies, right? What else do I know? Okay, what is that? Okay, what else do I know? What's the common ratio? 2, right? All right, so we'll finish this up next class. Make sure you finish your packet pages 8 and 9. And I will see you guys Monday.